Welcome everyone. Thanks for joining this session on Public Health Automated Case E-Reporting, also known as PACER. I am Tia Pope, Director of Health Interoperability within the HEAT Division, or Health Emerging and Advanced Technologies at Georgia Tech Research Institute. I'm joined by FHIR certified leaders, researchers, and innovators within my branch, Myung, Choi, and Michael Riley. In this talk, we'll cover an overview of PACER, provide a quick demo, share about our pilots and what we've learned from them. From there, we'll wrap up with our plans for building an analytics pipeline with PACER and our next steps. Feel free to drop your comments or questions in the chat as we go. PACER is an open source platform that we've built to modernize and automate the case reporting process that happens between provider systems and public health agencies. This is done by leveraging HL7 messaging and FHIR. It was built for reporting on infectious diseases such as chlamydia and gonorrhea, but could easily be adopted for others such as COVID-19. PACER is well suited for case reporting data flows that require lab confirmation via electronic lab reports, but could also be triggered by other means such as an encrypted fax. With PACER, health systems have full control of the data shared with the health department and can filter down to the most granular levels using privacy filtering as well as other features within PACER. Provider systems can also allow the public health department to make multiple automated and secure calls to update case report data over time. Predefined questions to support relevant data sharing is another layer of control that health systems have to ensure expected results. PACER is a great complement to other modernization efforts and interoperability tools available to support interoperability and secure data sharing throughout public health. To ensure PACER can support as many health systems and public health agencies as possible, it is system agnostic and allows users to utilize their existing infrastructure, whether that's Windows or Linux-based, hybrid, cloud, or completely on-prem. It is compatible with other interoperability tools and is containerized for ease of deployment. Privacy filtering again allows for granular control of the data and clear auditability. It provides a complete package for automated case reporting. If you'd like to learn more, feel free to check out our publications on PACER and the work we're doing to transform public health case reporting. Now, Myung will provide a quick overview of the PACER data flow and demonstrate how PACER captures case information by sending 3 ELR messages to simulate data flowing to a health department and review the changes from an initial case report.
This demo shows how positive electronic lab report triggers a PACER client to send a request to server to get the data from EHR. This demo will start from sending positive electronic lab report, which will create the initial case report in the client, and then triggers a request to the server. The request will be periodically sent to the server in every 2 minutes until the reasonable data coming back from the server. Server will use the CQF logic to create the FHIR query, and from the FHIR query, you will get the data from EHR, which will send back to the client, and the client will use that data to augment and update initial case report. Okay, all right, so let's start the demo. So we'll be sending 3 ELR messages back to back. And sometimes it happens so quickly. So what we are going to do is we are going to run it and verify those 3 messages are accepted by receiver at the client. Once we verify the accepted message, we'll quickly go to the PACER client dashboard. And so we're going to have a chance to look at the initial case report before it gets updated. All right, so let's send the data. So I have a small Java-based ELR sender, which will send those messages back to back. All right, now it's sent. Now we have 3 accepted message. Let's quickly go to the dashboard, and let's reload it. Now we can see 3 initial case report is created. So I'm going to quickly click on one to see the initial case report before it gets updated. As you can see, all the clinical data are missing, or actually it's empty because it's not available in the electronic lab report. However, we have a lab result coming from OBX segment in the electronic lab report. So let me see if we can see the third one before it gets updated. This one as well has no clinical data, but the lab results. All right. So I think we received the response from the server. So let's look at the first case that we saw, which didn't have a clinical data, but now, as you can see, we have a clinical dates, and we have diagnosis, and we have medications as well. So and also symptoms. So as you can see, the clinical data which were not available from the electronic lab reports is now showing up here because the PACER platform was able to retrieve those data from EHR. Right? And then let's look at the another case here. Also, this one has has a diagnosis and has a symptoms. Those are like clinical data. All right. So we were able to augment the initial case report with the data that we got from EHR. All right. This concludes our demo. Back to you, Tia.
Thank you, Myung. Our first pilot was with MUSC, where PACER was run for a series of 8 weeks, where 117 cases were identified. And as you can see below, PACER provided a lot more data than what just the ELR could provide, just as you saw in Myung's demo. And this includes condition information, medications, diagnoses, demographic information, and so on. Right now, we're in the process of piloting PACER at 2 large US-based health departments with their respective clinical partners in partnership with the CDC and Public Health Informatics Institute. We anticipate these pilots to conclude by the fall, and we're really excited for the opportunity and cannot wait to share the results with the community. So far, some notable lessons learned include the importance of having a trained workforce in basic IT concepts, networking, and security. For instance, automated TLS configurations and unique IP addressing have been areas we've spent time providing training for our partners. Containerization and IT policies don't always align, but that's okay. I could go on about that, but since we're limited on time, I just will say that the most important takeaway so far is to not underestimate the value of patience and the positive effect of humor in a high visibility pilot. Now we're going to transition to Michael, who will discuss the future of PACER.
Hello, my name is Michael Riley. I'm a developer on the PACER platform and a FHIR certified developer. I'm here to talk about what the future next steps are for this platform. So as we saw before, we have a good way to separate concerns from the FHIR standard community and public health needs. FHIR introduces an EHR standard that allows us to use a common language for this web communication, these REST resources. However, applications want to work with this medical technology, but they can't separate the mechanisms of retrieval and review from their application workflow. So the goal of our PACER project here really is to remove that logic of retrieval and review out from the client application into a centralized place in which public health and maintainers can review and evaluate and iterate on. So when we think about the actor space that PACER lives in, we have medical providers that are quickly becoming FHIR enabled with their EHR communication standard of FHIR. Application developers have lots of concerns, even unrelated to accessing the data of FHIR itself. They also need to maintain different kinds of user session management, application integrity, workflow design. If possible, application developers would not like to have to reinvent every medical definition and cohort definition that they have to worry about. If a public health consortium could maintain a specific set of medical definitions and criteria that could be standard and reviewable by the public at large, that could be a benefit and extreme use of separation of concerns for these application development cycles. And here's a diagram describing sort of those actor spaces here. The standard community providing input and information for medical providers to create that FHIR standard, while PACER interacts with clinical reasoning technology, interacts with public health officials and developers to create those standard definitions that application developers can use for their concerns, separated from medical resources, separated from any of those concerns. They can work with their own data, but still work with FHIR-enabled data as well. On this slide here, we can sort of see the workflow from initial definition, which will usually come from a form, into a computable query and an analytic query that we can run that's used by different applications with their analytic engine to create an eventual form report. And on the right-hand side here, you can see a workflow in which some health department initialization happens from a laboratory system. That sends a request of jobs to be run to PACER. PACER then works with a server on the provider side, a client in the development side, to marshal a request for job information. It goes to analytics engines, in this case it's just the CQL engine, and pipes back out to the health department as the client application. To create these computable analytic definitions, we use a language maintained by the database consulting group called Clinical Quality Language Scripts. It's a query-based language, very familiar to any type of relational database schema out there. It uses a query, filter, shape, and sort definition. And it creates a reusable script that's human readable and reviewable, fairly human parsable as well. And it uses an abstract data provider, meaning that it can work with systems other than FHIR, but we primarily just use it for FHIR purposes. So before we get into a specific CQL script example, I wanted to talk about the types of questions we tend to answer with CQL. These are generally sorts of medical contexts you would see in a traditional retrieval application, such as a patient enters an emergency room but has a complication event with an adverse event. A patient goes to an emergency room for some sort of bleeding system, has a specific type of complication from earlier, INSAT or something like that. So these are the types of questions we can answer with CQL in a generic form and reviewable form as well. And on this slide here, we have a simple CQL retrieval and shaping example. This will go through the query, filter, shape, sort definition, although no sort is in here. On the red and yellow lines, we can see their expression definitions. Yellow lines are retrievals. Green and blue are related retrievals, so we're retrieving a syphilis condition and then creating a syphilis diagnosis afterwards. And then we're shaping the response into a dictionary type structure called a tuple that collects all of our information into different FHIR resource fields, different questions we were trying to answer, what the actual answer was from any of those resources. And so you also need an engine to run CQL against, and the engine we use is another provided one by DBCG called CQF Ruler, or Clinical Quality Frameworks Ruler. It's a Happy FHIR server, actually. It's an extended Happy FHIR server that provides clinical reasoning modules. So those modules are things like libraries, questionnaires, activity definitions, and it provides custom operations you can run to actually invoke the CQL engine. So there's an evaluate operation definition for running CQL with this server here. And so when we're making our explicit CQL definitions, as we saw earlier, we run through some very simple steps for doing so. First one is to determine what the definitions should actually be required are. Then we assign different resource and concept sets that we're going to retrieve from the FHIR server that identify that positive operation. Then there's a filter if there's a temporal concern, such as you need a previous condition or some sort of values in which you're only looking for, say, highly severe cases. We apply that filter. Once that filter is applied, we assign a question concept ID as well to a local question concept set and create that tuple, as we saw earlier, that insight tuple. And so to elaborate on our shaping of our response here, we use a local question concept set we created, which we assign to a question concept field within what we call an insight tuple. And this insight tuple are answers for that any given question answered by a specific FHIR resource or other supporting FHIR resources. So that's why we have a FHIR resource ID pointing to the source ID of the resource, what path we use to identify the correct insight for this question, the source note, what's the text coming out of this stuff, what's the actual answer being assigned to the data set at the end of the day, and what's the value type being used for that answer. And so far, we've only been talking about structured data coming from a FHIR server, but PACER also has the capability to work with unstructured data as well through a framework called Clarity NLP, or Clarity Natural Language Processing for clinical reasoning. It's a framework for working with simple unstructured data, such as doctor's notes, text reports, and provides different levels of tasks for identifying things such as term sets, positive provider assertions. And we've developed another language as a sister language to CQL we call NLPQL, or NLP Query Language. It's structured in the same way. You have different types of library names. We call them phenotypes in this case. We have different term sets instead of concept sets. And we define Clarity NLP tasks to be run instead of expression definitions. So in this example here, we have a widowed definition. The provider assertion is to try and find a positive case in which the terms widow, widower, widowed, husband died, or wife died appeared in the text, and that would be an assertion of a widowed person. So pulling it all together, since we now have multiple analytics engines and many different clients that can request results from PACER, we use a new middleware API framework we call Results Combining API. This API works with different job package statuses, understands which CQLs and NLPQLs are relevant to a given job package, and requests in parallel both NLPQL and CQL to be run against either the FHIR server or a document store, providing which one is being asked for. Our CPI then marshals the response and creates a return bundle or results bundle, depending on which client is asking. And finally, we have internal workflow for how we create these clinical modules, whether in CQL or NLPQL. We want to define a need for what that module will be, then the clear questions that are being asked of that module, which insight should we be created. We do a review of the medical literature that's relevant, trying to identify the correct cohort and criteria for identifying any given question. And then we build these reasoning definitions either manually or through some automated process to do a translation, either from an Odyssey cohort or a Cynthia definition. Then we move into testing, where we test these patients in a sandbox environment. We build against the specific definition, and then we work towards a general population from there.
Thank you, Michael. For our next steps, we intend to build a stronger population cohort for testing, spend time researching a bit more on Smart on FHIR authorization options for PACER, as well as ensuring we have the leanest deployability that we can to support ease of use as well as access for the community. If you have any questions or thoughts you would like to share regarding PACER, feel free to email us or reach us via Huga. We will now take your questions. Thank you.
All right, and thank you to Tia, Myung, and Michael there. I'm going to go over to Huva here and start looking at questions, but I'd like to open up the floor here. If there's any questions over voice, please go ahead and ask them. And I'm going to pull up Huva here and sift through these. 1 second, please.
Yes, thank you, Joshua, and welcome everyone who was able to join us. I think the first question was regarding the audio, so I do want to address that. So in the upcoming recording before it's published to YouTube, we'll be sure to circle back around with H07 and FHIR to make sure that it's updated and added so that you can hear the audio on the demo portion. All right.
All right, and then it looks like the next question there, Tia, is to what extent does PACER align with or tackle different challenges than the FHIR ECR IG?
All right, we're going to have Myung address that one, and I'll add any extra to it.
Yeah. Right. So can you hear me?
Mm-hmm.
All right. So basically, our the target, our goal was how we can deliver the case report electronically without giving the less burden on the EHR. The ECR workflow, as far as I understand, is a push model where ECR has to have push mechanism implemented along with a FHIR. In our case, we turned that into a pull. We use a pull as our message delivery model, so that we basically can use existing FHIR server, and we can work with like a FHIR vendors or providers FHIR capability, and we can work with them. So that's what we are doing right now, actually. So we are working with them to be able to pull the data into it. So we see that as a like more complement to the ECR, not instead of like doing one then the other. Or more like there is like a FHIR ECR, and we believe that PACER can be a complement to that existing ECR standard.
Yes, thank you. And yes, to piggyback on that, one of the pieces that we've actually have been in conversations with some of our partners, including the health departments, is seeing how we could build out a ECR specific export functionality within PACER. Right now, we're keeping it pretty general just because we're trying to get through the pilots right now. But that is something that we are looking to do moving forward. All right, any other questions?
No, I'm sorry, Tia. I don't see any more questions in Whova, but we are at time, unfortunately. So I want to thank you again, Tia, Myung, and Michael. And for those of you joining, I appreciate you joining. And please know that if you have questions afterwards, you can continue to ask them in Whova under either the messages or under this chat in this this session, and the speakers will be happy to answer your questions there. So thank you very much for joining, and everyone have a great day.
You too. Thank you.